It is in the form a plus bi. Remember that? Okay. So if we're over the set of complex numbers and we get a negative under the square root, we can proceed. All right? And since this says we're using the quadratic formula, that's going to be what we do. But first, let's go ahead and rewrite this first equation so it's in standard form. So we're using the quadratic formula correctly. So we're going to move the 125 over. So we have x squared minus 20x plus 125 equals 0. Okay. All right, now we can plug into the quadratic formula. So x equals, because that's a formula, right? Opposite b. What's b? Negative 20. So negative 20 plus or minus square root of b squared, so negative 20 squared, minus 4 times a, which is 1, and c times c, which is 125. Oop, my square root wasn't long enough, so got to fix that. And all of this is going to be over 2a, so 2 times 1. All right, so in the calculator, what goes in the calculator? What part of this? The stuffing or the discriminant, right? And we don't include the square root. Okay, so if I plug that in to the calculator, I'm just going to go ahead and tell you this is going to be negative 100. Okay, so x is going to equal positive 20 plus or minus the square root of, and if I typed that in exactly as I've written it, it's going to give me negative 100 all over 2. Okay, now we can deal with this, right? So I'm going to go off to the side here because I don't really have a ton of space, and kind of jot this down here. If I have the square root of negative 100, okay, the only part of that makes this not able to work with is the negative under the square root. So I could say this is the same thing as the square root of negative 1 times the square root of 100, right? And we have a way of dealing with the square root of negative 1. What is the square root of negative 1?
0.
It's I. Yeah, it's I. And then the square root of 100 is 10. And then we're not going to write our answer as I10 because that's a three-way. It's 10i. Yeah. So the square root of negative 100 is 10i. So if I come back over to my work here, I have x equals 20 plus or minus 10i over 2. Okay? All right, now, we cannot leave our answer with a real and an imaginary sharing a denominator, right? They're in different dimensions. They each have to have their own denominator. So I'm going to say, well, x is 20 over 2 plus or minus 10i over 2. And then can we not just simplify those fractions as they are? Yeah. So 20 over 2 is 10 plus or minus 10 over 2 is 5. So 10 plus or minus 5i, those are our solutions. One's 10 plus 5i, the other is 10 minus 5i. Okay? All right, so far so good? Cool. All right, let's take a look at what happens in example 2. So this one's already in standard form. Zoom back in on this one. Already in standard form, so we can plug in x equals, in this case, b is the number negative 1. So negative 1 plus or minus big square root of negative 1 squared minus 4 times a times c, which is also 2. All of that is over 2a, so 2 times 2. All right. And then we can type in our discriminant, although I could probably figure this one out mentally too. Yeah, it's 1 minus 16, so it would be negative 15. So x equals negative 1 is 1, plus or minus the square root of negative 15 all over 4. Okay, now if I keep going, all right, so I could pull out the negative as I, and then I'm left with the square root of 15. So I have I times the square root of 15. If I try to break up 15, we get 3 and 5, but there's no pair, right? So we can't simplify it. It's just going to be I root 15. So x is going to equal 1 plus or minus I times square root of 15 over 4. Can I leave my answer like that? No. Yeah.
Why is it 10i but not 15?
Good question. Why was this one 10i? Because 100 was a perfect square. The square root of 100 was 10. But 15 is not a perfect square. So I have nothing I can't simplify the square root of 15. But I could simplify the square root of 100.
I meant like the placement of the I.
Oh, the placement of the I. Okay. We always write our i's in front of a square root, but after a whole number. And it's because of the convention of we don't want to, if I put the I here, it could look like it's also under the square root, and it's not, right? Because it came out as I. So that's just a convention. But that's a good point. Like if I go to write my final answer and I split up my denominator. So I have 1/4 plus or minus I times the square root of 15 over 4. That's one way to write my answer. But another way to write our answer is, to make this literally in A plus BI form. So I could also write this one as 1/4 plus or minus the square root of 15 over 4i. And then that one literally looks like A plus BI. What are you going to see largely, like on the answer keys and things, you're going to see this first one more often than the second one, but it is still legit. Okay? All right, so we had one example where we had, perfect square with I. Another example, we couldn't simplify it. And in this third example, we get the other instance that we could have. But first, no, that needs to move over, right? 3x squared, we'll add 4x plus 3 equals 0. Gotta make sure we're looking in standard form. All right, so quadratic formula. X equals opposite b, so negative 4 plus or minus square root of b squared minus 4 times 3 times 3 all over 2 times 3. B plus or minus b squared minus 4ac. Okay. All right, and then discriminant would go in the calculator, but let's see if we can figure this out here. 4 squared is 16. 16 minus 36. What's 16 minus 36? Negative 20. All right. So x is going to equal negative 4 plus or minus the square root of negative 20 all over 6. Okay, so let me go off to the side here and figure out the square root of negative 20. Well, the I comes out front, right? So I know I have I times the square root of 20, but the square root of 20 can be broken up. Yeah, so this is, if you think of it as under the square root, 4 times 5, the square root of 4 is 2, so it's I times 2 square root 5, right? The I, sorry. So then, where does the I go? To the right of the 2, in front of the square root, in between. Yes, that's where the I goes. So the I is going to go right in between those. So we're going to have x equals -4 plus or minus 2I square root 5 all over 6. Yeah, and now here's the thing, like there's that triangle for simplifying, right? When you're doing the quadratic formula. But that triangle doesn't really apply when we have a complex number situation because you're going to end up splitting this up. So the triangle doesn't matter. So what I mean by that is we have to give each of these their own denominator of 6. So let me bring this up here. So x is going to equal -4 over 6 plus or minus 2I root 5 over 6. And then, yes, then we can simplify. But I don't have to look at it as 3 numbers at once. I can look at them as 2 separate fractions. So -4 over 6 simplifies to what? -2/3. And then 2I root 5 over 6. I'm just looking at the 2 over 6. That simplifies to 1/3, right? So just I root 5 over 3. So in the solution set, I'd put -2/3 plus or minus I root 5 over 3. Or another way to write that, right, is to say it's -2/3 plus or minus root 5 over 3I. Does not matter. Does not matter which you choose. Answer keys are going to look like the top one, though. Okay? So, paying close attention because like, when do you know when to do the I, and when do you know just not, and say that the answer is no solution? It's all in the directions. What number system are we in? Where are we living? Yeah, this one is telling me I'm in the complex number system, which includes imaginary numbers. But the quiz, solve each equation over the set of real numbers. So this one's like, okay, I'm just operating in that smaller subset of numbers. So you got to read to know which one you do. Okay? Y'all good? All right, so let me